My name's Catherine Felt. I'm the Executive Director for the Frank Lloyd Wright House in Ebsworth Park, and we are undertaking a $1 million roof restoration, bringing the roof back to the original intended cedar shingles and the original design of Frank Lloyd Wright. He designed this and other Usonian properties based on a dominant geometric form, and he created then a grid. It's just a parallelogram, 4x4 unilateral parallelogram. So the plans that we have are very rudimentary, to say the least. So heaven forbid something really catastrophic happens to the house, we can recreate with such precision an opportunity to rebuild or take corrective action. So that is so invaluable to us for the preservation of this house.
My name's Harvey Wright. I'm the AECO Strategic Account Rep for Seiler Design Solutions, and this project came about after I took a tour of the house. I've lived in this neighborhood for 32 years, and I had never seen a Frank Lloyd Wright house in my own neighborhood. And it was very serendipitous that they were getting ready to launch this roof project. My proposal was to laser scan the exterior and the interior using an XGRIDS Lidar scanner and be able to document existing conditions and have a digital record of the house going forward.
It's very important for us to really assess what the conditions are at this point before we undergo the re-roofing process. It'll be helpful for us as we take on other preservation. Now with this technology, we can make sure that there's no masonry or other elements of the roof or house that are compromised during the process.
This is XGRIDS K1. It basically weds two different types of technology together. So we've got two 48 megapixel cameras here that capture existing conditions in a pano type photograph. And then we have a Lidar sensor up here that generates a three-dimensional point cloud. Now, this RTK antenna, it will actually give you a real-world coordinate as the basis of your scan. What we're finding is that the positional accuracy that the RTK provides, it enhances the dimensional accuracy of the scan itself. The setup for it was basically walking the site, making sure what our trajectory was going to be through the house and around the house, and making sure that we could document all the conditions. And as you can see, we have really nifty roof access here, so we could get on top of the building and scan. And then since then, we've actually done, with this unit's big brother, we've done the entire site out here. So we've got a contour of the whole site. It generates really beautiful photo imagery that is on top of a highly dimensionally accurate point cloud.
The Seiler team was professional. The scanning itself took no time at all. We did a few scans in between our public tours, so it was not disruptive. There's a great deal of confidence knowing we have a digital image of the house as exists now. It was remarkable to see the scans, how incredibly precise they were. There's some things we looked at about how in the future we can use this as a virtual tour, bringing essentially thousands of more visitors and people who physically aren't able to come to the house to see it.
We have a beautiful digital record of the building as it stands. It's very new technology for us, and every time we scan something, we're learning something new about the unit. We'll continue to scan out here and have a kind of a progress monitoring. And then obviously when the roof is on, we're going to come out and rescan too, because it's going to be, I think, a much different looking house with the cedar shake. I mean, it's just been wonderful working with the foundation and Catherine and being part of this project.
So with Seiler technology, I feel like I'm in partnership with Harvey and the Seiler team, able to really do a good job as a building steward and provide resources so that this house truly can endure for the future.